Okay, so it looks like we're live. I think we need to turn this light on. That's how we ended up doing it last time. And then I need to make an adjustment to the camera here real quick. You can go ahead and stand up right now. All right, so you can kind of see behind you like where you would need to stand, so you're inside the view of the camera. And you know what's really nice if you can is that you can stand out here and so everybody can see the screen, and then when you talk, maybe move into the screen so then we can see you. So just for everybody that's there. And then this is where you can go ahead and log into your email and then get started.
Are you in Google Drive? Aren't you in Google Slides?
The drives or something? So
Omar's
gonna. Oh yeah, she did. She did say on Tuesday. He's gonna help me with the
I'm
article.
slides 1. Okay, good.
So you slide 1, I'm slide 2.
I'm slide 1 and 6. Or 1 and 7. What? Yeah. Alright, so sorry, I'm like losing my voice. We did.
Oh, wait, I'm sorry. Everyone, they're going to get started, so phones away. You should have nothing out. Make sure you give your undivided attention to them. And then have questions.
Alright, so we did sandbars. Yeah. So our issue is that sandbars are developing in rivers, and that doesn't allow barges to travel. And sandbars are long, narrow sandbanks in rivers. Barges are pretty much boats. And for our solution, dam, which is a barrier constructed to hold back water. Yeah, there's some pictures. This is a picture of a sandbar over there. This is a picture of a dam.
All right, so water starts to slow down and it creates sandbars, and it starts off as straight theme, and then it forms meanders and floodplains. And then the sediment will not move anymore. The measurements we took was 62 centimeters, 45 centimeters, 54 centimeters, 29 centimeters, and the width was 17 centimeters. You hear the video screen?
This is what I think Mr. Z's talking in this one, so he's kind of explaining. What?
That energy isn't moving anymore. So as it makes these kind of turns and meanders here throughout the model, we can see that it slows down over here on the inside and the sediment gets dumped. So that's explaining that the meanders form. So now, if you were to, like, let's say, drop a piece of paper.
Right. And then here's the other one, which just, oh no. Here's the other one, it's showing them forming, and I don't know why it's not. It's not working. The escape button isn't working. I'm clicking escape, it's not working.
It's not. Yeah, that's how you won't work.
Is that flow from Progressive?
That's my driver's license. I got this one.
All right, so this. Oh no. So this is the and there it goes again. Well, okay. This is the video, and you'll see the sandbars forming. Yeah, you can see it's forming there.
I don't know, would this be considered long?
Yeah. It's gonna go on for like 2 minutes. So.
Okay, so what we created for the dam is that we made a straight line basically so that the stream wouldn't make meander falls and all that. And then we put a wooden block in the middle so it would be the dam. And then we put these two barriers right here so that the sediments wouldn't come in to make the sandbars. We made it to an upside down V shape so we would control the level of the water too. And we put these two plastic barriers so that the sediments wouldn't come off from these two endpoints. And yeah.
So our solution, what he was explaining, was to build a dam to control speed and prevent sandbars and meanders and to make the river more narrow. And so as the discharge increases, so will the velocity. And okay, here we have a video of our solution with the dams. And you'll see that it doesn't create sandbars. Yeah, so pretty much you wait for the water to fill up, then we take the dam off. And then here's the other video. I made a little boat. So for the barges, so the barges won't get caught in the sandbars. So. Oh, I guess it's not gonna do that. Yeah, so the boat happily floats to the other side.
All right, so the references we used the Three Gorges Dam video. So the video is saying that the boats couldn't travel because of all the water and the flooding, and you couldn't transport anything. So it was like we were controlling the water from our video like it was controlling the water in the Three Gorges Dam video. And so the dam was wider and deep, and it eliminated the sandbars.
And for the article, it talked about how sandbars were blocking the rivers from the Mississippi River, and it was creating traffic from the boats.
Yeah, that's it. Yeah.
We're the sandbar group. And what's a sandbar? A sandbar is a narrow sand bank. And what's the problem with sandbars? Barges get stuck, boats get damaged, and boats can sink. And I have an example of a boat getting stuck. It's the best thing. You can see the boats getting stuck on the sandbar. And that could lead to damage or puncture a hole into the boat. What the? What's
How sandbars are their barges get stuck and like boats will get damaged and they sink and stuff. And it stops resources from getting to other places. Variables that change in the experiment is the stream current and the area. We put up 2x4s so sediment couldn't get through and increase the stream velocity and discharge.
A barge is a flat bottom boat for carrying freight, or it could be towed by another boat. And it's typically in canals and rivers.
So I'm just gonna I'm gonna pause it. Okay, so on this, when we were using the stream tables, we were supposed to replicate a older river, so the Mississippi River from our article, and by doing that, we slowed down the We slowed down the velocity of the river, and we let the water run on its own. And when it did that, you could see like that the sediments weren't like the stream was going slower, and so the sediments didn't have really anywhere to go, and so you would see like the sandbars starting to form. Wait. Okay, and so then this is us just like letting the water run and letting sandbars start forming on its own.
So it just was really showing where the sandbars were flowing and what pressure we had the water at. This one.
Wait.
So a solution to our problem for the sandbars, we build a channel.
So right here we put up 2x4s, and then we also put up like metal tubes in the middle of these so they would hold up the 2x4s so the sediment in the on the sides wouldn't fall. And so because the channel is making like a narrow passageway, it increases like the velocity of the river, making the sediment move down faster so it won't get stuck.
You wouldn't build up any sandbars.
But this is like a temporary solution because over time then the the sediments start to like build up over here.
Pros and cons of it. It stops from sandbars occurring for a little bit. Lets barges transport resources and it increase river flow, but you'd have to do regular maintenance. If there's enough water flow, then sandbars can still occur over time. It could make the river flow too fast to keep control, and it costs a lot of money to repair any damages.
That's it.
You got a question?
Yeah. Esa era la news. We are the Delta Group.
Okay, our claim is the Mississippi River will change course to create a new delta without human intervention, and our hypothesis was the Mississippi River will not change course or be able to create a new delta without human interference, and we were proven wrong. So if you guys don't know what a delta is, a river delta is a landform that forms from deposition of sediment carried by a river as the flow leaves its mouth and enters a slower moving of standing water, such as like the Gulf of Mexico where the Mississippi River real world significance, the Mississippi River changing the location of the delta can affect houses, businesses, local economies, wildlife. Losing land, every hour a football field of land is taken. Okay, and right here is coastal Louisiana today and what it will look like by 2100, unless if we don't do anything. So
This is what we do not want.
Yeah.
This is bad.
okay, and the first video is showing what we don't want. Yeah.
So just imagine this as the Mississippi River.
And that's the first delta it's creating, and then it's taking away a lot of land.
As you can see, as more pressure from the water comes down, it starts to create more deltas, and that's what we don't want to happen.
It changes direction too.
Yeah, as the sediment builds up, it has to change because it doesn't have anywhere to go.
And then as notice how the river just got wider too.
Yeah.
So
Because all the sediment was taken from the sides.
and it's creating a new delta at a different
And it was-
location.
Yeah, it's sitting right there.
So our solution was oh, yeah. So our solution was to create a diversion of the Mississippi River, or one with like a channel basically with wood planks blocking off the sediment from being taken away, and another one to control where the sediment in the delta forms. So basically, that's one stream and that's another one.
So by having two exit ways, the water can split without causing damage to the homes or environment around it.
Started.
Now you can see when we have our two pathways, the water can either diverge in the two exit we created.
Yeah. So
So we just explained this.
okay. So
So, I mean, if it's 2,000 miles, you already know it's gonna affect a lot of lives. So basically, what we did first was make the stream curvy, and like it didn't work. So let's see.
Okay, the qualitative and quantitative data. River length is a difficult measurement to pin down because the river channel is constantly changing. So by creating the two pathways, we made it a much safer environment for and cleaner. So the water can come from. And at the headwaters of the Mississippi, the average surface speed of the water is near 1.2 miles per hour, roughly 1/3 as fast as people walk. So when the velocity of the water comes when the two exits diverge, it becomes more uh, a more stable environment. So the river can become safer.
Yes. So as we showed in the videos, we put boards on the sides, and we also created a new river. So instead of all the water going one way, it wouldn't just go one way, fill up the whole sides, take sediment, and create a new delta. It would go both ways and combine in the end.
no, we already went over this.
Any questions?
Yeah, we already went over it. So yeah, the Mississippi River can be destructive. That's why people are working for it to have a constant delta. Any questions, comments, concerns?
Okay, so our group is doing channelization.
And we're trying to prove that channelization is actually causing flooding and more problems for the area around the river.
One real world example of channelization is the Kissimmee River in Florida. Before channelization, its floodplain was about 3 miles wide, and in 1947, flooding had become so much of a problem that the public even had to ask for federal assistance to fix this. And by 1960, they were actually able to channelize the river, and they made a 30-foot deep straightaway through the meanders. Except this caused a lot of problems for the environment, such as destroying the floodplain, which threatened the civilization around there. Like native species were endangered, animals, fish, and wetland dependent animals were I lost my train of thought. Endangered and put close to extinction. And another animal that would be endangered is the bald eagle.
So what is channelization? It's pretty much just a way to modify a flowing river to carry water more efficiently and reduce flooding. So any type of like human interference with the river, it's mainly just to make it flow more narrow. And so this is.
So yeah, we have a video of a natural kind of river that has like cut banks and point bars.
It's not. Oh.
So in the video, you'll see like meanders, which are the curves, and in the meanders, there's cut banks, and those form along the inside of the river, and that's where erosion occurs.
And there's also very large floodplain too. So
And the river also has point bars, which are the inside of the meanders, and that's where deposition occurs.
channelized river flow. The structure is built, river flows more straight. It eliminates the natural floodplain. It gives communities surrounding the river a false sense of safety, that they won't get any more floods. But also, most of the time they have to cut land to make it straight. So yeah, this is what it looks like.
So basically, like what we did was make like the river in a couple different ways, like a more natural way and kind of like a channelized way, to kind of show the difference when it comes to like heavy like rainfall and how much river or how much water is in the river.
And then here we have a video of the channel flooding, which is a lot more dangerous to the surrounding communities. So there was no like natural floodplain, and when the river is natural and has like its meanders and everything, it's longer than the channelized river, and so the river doesn't have like the same amount of room that it had originally to flow. Oh yeah, this is kind of just what I just said.
Yeah. So the problem like with these kind of channelized rivers is that is when you take away the curves and everything of the river, it shortens it up and makes it easier for water to kind of like flood.
And then here we have a video that shows our solution to the problem. We basically created channels from the original that lead into these gigantic bowl shapes. You can see like the water going from its path, and then it goes like into the bowls. And then these are our sources. Any questions?
All right, I want to show one image here that I pulled from another group. And to really just kind of sum up the presentations, and a lot of them were really, really good. But taking a look at this, and I'll get to this picture in just a second, a lot of the solutions that were offered ended up being channelization. For somebody that was in the sandbar group, we make a channel and the water velocity increases and we don't get sandbars. To control sediment from getting into the delta, we make channels. To control sediment entering in a dam, we make channels. It's a really popular method for fixing a lot of problems. And what was unique about the setup of the presentations is that then the D group then presents channelization and what's the problems with channelization. Taking a look at this like back-to-back image over here, the image on the left was taken at some point in time in the past, and then the river was then channelized, and now that is the image on the right, however many years into the future. So as you can see, which was presented in both of the channelization groups, that the length of the river is obviously decreased from where it was to what it is now. The other thing that you should notice is that the width of the river has also been decreased as a result of channelization. The areas adjacent to the river are the floodplains, which were explained by the groups. And the river is going to flood. There's nothing you can do to stop it, right? We can manage it in a lot of different ways, but for the most part, we can't stop that from happening. Taking a look at this river currently in its state, it's not going to be the same, right? In 10 years, 20 years, 30 years, these meanders are going to continue to grow and move in different directions with the erosion and the deposition, etc. It's not going to be the same. Well, that's going to be a problem for this building that's here, or for some of the other structures that are in and around that area that are using the river. They can't afford to not have their structure there. So that's why channelization is really kind of a good method of keeping the river at bay, so to say. So with the channelization then that was done on the right, you've now changed the river dynamics. You've stopped it from continuing to grow and meander, etc. But then what you've also done, which the group had mentioned, is that you've created this kind of false sense of safety in and around or adjacent to the riverbanks, because that's still a floodplain. So this invites people to this area, right, that are at risk of them being underwater at some point in time in the future. But just making that synthesis between what the other groups used as possible solutions and the problems that they fixed also then put you at risk for other problems that are out there. So studying river dynamics and people, engineers and things like that, I mean, nothing is foolproof. And yes, you can construct one thing to solve 5 problems, but then you end up creating other problems as a result of that. So, but I guess it's more of which problems are worse, and then the decisions get made. So really good presentation by all the groups today and last week on Friday. I'm hoping to get those grades in soon as we can. So the next thing we want to do is go ahead and fill out this reflection, and I'm going to talk about it. So I'll just pass out just a stack of them. I'll collect them on the end. Now, so this sheet is double-sided, and you're not filling it out with your group. You're just filling it out individually. And if we take a look at the questions, some of them are really straightforward, and other ones require a little bit of explanation, and I'll go ahead and do that now. I do want you to take this seriously, as this is a part of your grade for this project. So the first question is really straightforward, which is basically just summarizing your project as a whole. Really easy. The second question is how you contributed, not your group, you to the group. Did you create a PowerPoint presentation? Did you build a model on the stream table? Did you watch Three Gorges Dam? Did you do what you needed to do? Right? What was asked of you? How did you contribute? So that's the answer to question 2. So question 3, if you were to create a portfolio of the best work you created this past week or 2 weeks, which artifacts or pieces of evidence would you want to include and why? So in other words, if I was going to assess you, which I am, like what would you want me to look at that really showcases your work? Is it the presentation itself? Is it the PowerPoint? Is it the video? Is it the information on this slide or on that slide? What tells me that is like directly related to the work that you produced? It's one thing to say that you did it, but then how do I know? What can I see in the presentation or in the overall project that lets you know that you did that? Right? Think about all those different things that are there. Question 4 is really straightforward. On the back side is a rubric. You're only filling out the rubric self-assessment for your group. So all the groups are listed here. You're only filling out for yourself. Any questions that you have or concerns, you would write in this box on the far right. So if there's anything that you want to let me know, then go ahead and write it down in that space on the right. So make sure you're taking your time, that everything is legible, and that you have good responses for all of those, as I am going to read them when totaling your final grade. When you're finished, I want you to begin watching the sedimentary environments video 7.1. I'm devoting class time to it because it's a long video, it's 20 minutes. So it isn't due until Thursday, but if you can get 10 or 15 minutes of it out of the way now, you'll find yourself in really good shape for Thursday.